Hey, this is Steven from Legit Tech Tutorials and the Green Engineers, and welcome back to my channel. So right now we're looking at DIY, working on the DIY metal milling machine, episode 6. I believe I am uploading which version right now? I'm uploading, oops. Oh, I'm uploading version 5 right now. Episode 5. So yeah, this is indeed episode 6. So today I am working a little bit on what this would look like if it were on the milling machine itself. So here is something to kind of get an idea. So let's go ahead and close this. And let's go ahead and show you. So again, this is the shredder. And let me go ahead and hide the model. And let's have it. Whoa, this is laggy. That's strange. I think it's because of the recording, the OBS. That's strange why it's so laggy. So yeah, basically this is the side cutting mill, and I actually just bought one. So let me go ahead and also show you which one I bought. So as you can see, this goes around and profiles out those holes. And then these here are the 1/4 inch blades left, and it goes around. And it does a 33 thousandths depth per pass. So basically what that does is in 3 passes you're pretty much done. So it just goes around, and then finishes up. So total it's 3 passes, but it takes a really long time because these you have to actually move very slow surface feet. I think it's like 250 surface feet per minute. And what we're going to use is we're going to use a 4-inch cutter with a 1-inch arbor that goes through it. And so basically if you take 4 inches, divide it in half, we have 2 inches. If you take 1 inch and you divide it by half, you have half an inch. So the 2 inch minus half an inch, that's 1.5 inch depth of cut. And so that basically is from the middle outward. And so we're gonna have, what we need on this guy is we only need like 1.1 inch depth of cut. So we're gonna have 0.4 inch extra. That's unfortunate, but they do not make any sort of I think they don't make, well, basically what I did, I bought a cheap one. I bought a Grizzly. Probably maybe not the best idea, but I'm gonna try it. It's a carbide tipped for 50 bucks. So if I break it, doesn't really matter, and it's a 1 inch, very similar arbor to pretty much everything. So let's go ahead and show you what this will look like. So this guy basically looks like that. So this is the Grizzly arbor. It's a 42 bucks, but I bought it on Amazon for $52, so I guess plus $9 shipping plus tax. It's cheaper on Amazon, so just buy it on Amazon, because here they want $10 shipping. So that's 52 bucks plus another $3 something for shipping, and I'm getting it pretty much the same day. Yeah, pretty much the same day. So yeah, it's a 4 inch by a 1/4 inch, right? Because this has got to fit. This is a 1/4 inch slot in here, and hopefully this is really close, because otherwise I'm gonna have to step up on it. So we'll see what the exact dimensions are. I mean, if the exact dimensions are not right, then probably return it and get a smaller one, then I'm gonna have to do 2 slots, right? That's not what I would like to do, but still. So this guy is an 8 tooth. So there are some other ones online. Let's see, such as some other ones that are like 80 bucks, like this one from Exact Tooling. Here you can see, so this is a 4 by 1/4 by 1 side milling cutter, 22 tooth. This is about double the price. I guess it would also work. Maybe I'll try this one next and kind of get an idea, but here it says 0.28 height, which is not that cool. So it's a 6mm width, which is smaller than 1/4 inch. Oh, 6 inch. What? That doesn't make sense. Anyways, So yeah, so basically with this guy, I have to, in order to get this to work, I'm going to try this on the Tormach at the shop or the jet manual mill at the shop. And basically what I have to do to get this to work is I'm going to machine a, I'm probably going to go without the keyway at first and just do a pure friction fit. So basically what I'm going to do is I'm going to have a 1-inch arbor here. I'm going to have a probably a 1, whatever this is. I'll mic it and figure out what this is. And then I'm going to lathe the rest of it down on steel as smooth as I could get it. And then basically it's going to have a shoulder. And then with that shoulder I'm going to put this, put it in here so that the shoulder presses up against this guy. And then on the back side I'm going to thread it up until, you know, this point, let's say, you know, and then I'm going to put on a nut as tight as I can and to shove it up against that back shoulder, and then I'm basically going to hold it there like that. And so this is actually going to be like an 1/8 and some change, an inch and some change arbor. Obviously I don't want to lose anything, but the bigger I make that arbor, the better it's going to fit. So that's kind of what I'm thinking right now. So put it in here, and as you notice, this thing's going to have to be extremely long because I do not want to flip it over because the positioning is going to be an issue. When I flip it over, positioning back to the same height, I'm going to machine this top part, but still positioning might be an issue. So this guy is going to have to be a 7-inch for this, and then a 10 to 12 inch if I get a bigger one. If I'm going to do the full 12-inch to fit in the flat rate box. So this is going to have to be really, really long guy. So worried about it not fitting in the tool holder on the tool changer at the shop, or also struggling to fit in the tool changer at when we build this thing. But it might, because we're probably going to do, if we get around to do a tool changer, it'll be an umbrella style, so that that probably should be okay. Alright, so let's go ahead and continue on. So let's go ahead and open up what we were doing before. So I should have probably had this open before, but that's okay. No, it's not this one. It's the green machine. Green machine mill. So yeah, so what we're going to do is we're going to put this guy on hold, and we're going to start to design the gantries. And then what I'll do is, off that website, like I said, I'll pull these guys off and import them in, because, you know, it's very time consuming. I showed you guys how to do that in episode 5, which I'm uploading right now. So here's the Y column, here's the Z column. And everything that I wanted to also check was is using I-beam. So of course, one of the things that I like to do with the I-beam is that it's a little bit heavier, and you have a little bit more choice as far as these boxes. Because let's look at Metal Online to see kind of what options we have. So we want some steel, and we want some view all types. There's a rectangular tube. I thought I just saw it. There's one right there. No. Okay, cold rolled, fine. Okay. Oh, okay, so yeah, see, this is very, very small wall, but let's see. Shape, we already got that. Square tube, alloy, blah, blah, that's not important. Wall, okay, so height. Okay, so, oh, the biggest they have is 5-inch, but what kind of wall? Ooh, see, they only have 1/4-inch wall. That's definitely not thick enough. Obviously, it's not wide enough. Let's put this over here, square tube. Let's try these guys. So they got some beam. Oh, there we go, square tube. Okay, so, ooh. Because what we're looking at right now is we're looking at some 9-inch. I did not think that they would not have 9-inch. But then again, 9-inch is the absolute. Okay, so they do have 1/2-inch wall. Okay, so let's see. What would something like that cost? That's the short one. Let's get this one, 38 inches. 38 inches. Ooh. So yeah, about 500 bucks. All right, so let's look at the beam. I think this is height by width. So we're looking for, like, you see these are too wide to fit inside the vise. So we would have to drop it down to, oh, you can't even get it small enough. Or that might be how tall it is. Because we don't actually need it to go in the other way. We just need it to go in this way. So this is probably the width here. So if that's the case, we could do this. 74 inches, that's really tall. Let's see what's the shortest they got, 8 by 10. Then we're going to lose 10 inches. But let's look at it anyways. See, $52, way cheaper than $240. Because I think that the square tube is a little harder to make than this. This is rolled. The other one I think is like extruded and then rolled somehow. This one is probably going to be easier to machine, just as sturdy, but probably not way as much. So it might be a little interesting to use this guy. I'm very interested about this, especially how it has these like chamfers, and this is going to stay extremely sturdy. It's not going to want to go. It's not going to want to bend this way. It's not going to want to bend this way. It's pretty much strong, and it's not going to want to twist because it has two I-beams resisting twist. So it's really one of the more sturdy materials. You don't really need these two, because it has resistance this way, it won't bend this way because it has this, as well as these two flat parts, but mainly this piece. And that piece is thicker. But we're going to lose an inch compared to our original idea. So let's look at some standard I-beams and let's create some alternatives. So let's go here. Oops. Oops. Let's add this to this. Okay. So now let's look at some standard I-beam sizes. This is millimeter. Standard beam. So this is a standard beam here. Standard S beam. This is all A36 stuff. Imperial inches, pounds per foot. So depth H. So we need W to be less than 9. So here 8. Depth is way too high. Depth is 24 inches. We want it to be as short as possible. Almost square. Well, almost square. It's almost double. Everything's almost double. So what is this then? Oh, this is CNC cookbook? Wow. Okay, so here's some standard. So standard I-beam, wide flange. So yeah, that's what we want. Wide flange, smaller depth, and a decent web thickness. So this is a wide flange. So this should be inches. Is this inches or millimeters? I think this is inches. So, but obviously the width can't be more than 9. But still. Okay, so we are coming down here. Okay, here we go. So it all really depends on what I could find. Most likely my supplier is going to be Sims Metal Management because I can get it for cheap. So I can build this thing for cheap. I don't have to get it shipped or do any of that kind of stuff. So, but other than that, I mean, we have what? 8 here, 12? 8, 10. Okay, now we're basically getting pretty much where it's square. Yeah, so pretty much the closest thing is this one. 8 by 35, 35 pounds per foot. And web thickness is, that's what that was. Web thickness is about 0.31, which is not that big. Because we could go up till close to 9. Eight, 10, 35. It's 100 pounds per foot. So this guy, well, obviously we'll want similar weight. So that's 38 inches. And that is the Y column. It's 183 pounds and 38 inches long, so it's about 3 feet. 181 pounds, right? 3 feet. 181 pounds, huh? Is that first column W? No, first column's depth. Okay. This is fine here too, actually. 3 feet. That's 200 pounds. Over ½ inch. Okay. So W8 by 67. Where's my Trello? Oops. Oops. So let's see if we can find this. It all really depends. I mean, pretty much what I'm limited to is what they have. W8 by 87. W8 by 67 or 87? W8 by 67. W8 by 67. Another thing that we could do is, we could cut the I-beam down on the width. It's not a problem. So it could be wider, but have a shorter flange, and then we just cut it down to the side. That'll also work. So maybe I'll have to this next week. I'm actually going to be off of school. I mean, not school, off of work. We have a shutdown, mandatory shutdown. So that might also be something that I could go by the Sims Metal Management and look at what we have to do. So what we have to work with for cheap. Okay, so W8. Where'd it go? W8 by 67. Okay, so let's do this. Rectangle. So this is webbing is 0.57. And this is from top to bottom. This height is 9.9. This is 9 inches. Okay. Then basically this is 8.28 divided by 2. 8.28, and then this is 0.57. And the same deal here. Or we could just draw a line, mirror it. Oops. It'd help if I drew my line. What? It'd help if I drew my line parallel. Okay, we got 8 minutes to make this happen. Sketch, mirror. Okay. And so now I'm going to call this, well, actually I'm not going to call anything yet. So let's look at general layout. This is 38 inches. So let's do that first, 38 inches. Let's call that Y. So we're going to call that Y, W8, 67, wide flange, I beam. Okay, now let's go ahead and go back here. Let's look at this one. 22. 22, and then let's call this Z. Oops. File, save as Z. Where is it saving? Oh, well, that's not good. Did they patch that? So now it doesn't do that? It's weird. Okay, well this is again supposed to actually be for the Y. The Y is 38, but this one's supposed to be 22. Save that. Save this one. And material we know is A36. Metal. I think it's all the way at the end after the alloys. A36. Close. Save. Save. Year. A36. Save. Okay. Okay. Oops. Okay, so now what we're going to do, back it out, and let's look at the weight here. Put in Z, so you like that. Put in Y, rotate it down, rotate it this way. Actually, it's supposed to be rotated this way because this, if you look at our view cube, this is the front. And so let's go like that. Let's joint it. Right back corner. This also makes it very easy to bolt up here or weld or do whatever. Obviously welding chances of it tweaking out are pretty high, but doing it this way is better. So there we go. And now this is a very sturdy table here. Okay, so now what is overall weight? Let's save it. So let's close this one. Let's close this one. Let's keep this one open. General weight 4628. 4628. Ooh, it's lighter. Huh. I wonder if that's because these are different materials. These might be not the right material here. No, it is the right material. Okay. So this is quite a bit heavier, but obviously we're going to struggle to find this thickness, and we're going to pay dearly for it. So we'll see. Basically what I'm probably going to do is, before the next video, I would like to check at Sims, maybe on the way home or maybe on the way out or something, before the next video, and figure out what I have to work with, so I could kind of go from there, because that's where I'm going to get the best deal. When my, I guess my inside guy is there, get the best deal that way. But now we could see the two different ways. So here is the beam style, and here is the general layout. Beam style, general layout. So we'll see what we have to work with. We'll probably work with either. This one might be easier because it's going to be a little bit cleaner. We could run stuff in here. We could have this thing bolted up here. The only thing that is kind of an issue is bolting up stuff here. This might need to be a welded together, and then bolted together here, and then like welded along here. Weld along here. And then keep some water here so it doesn't distort this front face, because then otherwise we got to go in and reshape all that stuff. Okay, so that's pretty much it for this video. This has been Steven from Legit Tech Tutorials and the Green Engineers, and I'll let you guys know what we have really to work with so we could kind of go further on and save some money there with the stock material and spend it more on some of the mechanics and the mechanisms that drive the machine to actually make good parts. Alright, so this has been Steven from Legit Tech Tutorials and the Green Engineers. Thank you guys for watching, and I'll see you guys next video. Take it easy. Oh, and then this is the end of episode 6. See you guys in episode 7. Take it easy. Peace.